In this video lesson, we are looking at acid-base reactions. So to get started in this handout, acid-base reactions. So the first thing we're going to look at is some common acid-base reactions. The most popular or known reaction between acids and bases is a neutralization reaction. So this is when you have an acid plus a base that react to produce a salt and a water. When we use the word salt, we're not referring to like sodium chloride, like table salt. Basically, we're just saying that we're going to make an ionic compound. The next example is a reaction between an acid and a carbonate, and it makes carbon dioxide, water, and again, that salt or ionic compound. So an example would be reacting nitric acid plus sodium carbonate, because our carbonate that we're talking about right here, CO3, just like that polyatomic ion that we learned about. So the reaction is nitric acid plus sodium carbonate makes carbon dioxide, water, and then sodium nitrate, either in a solid or a liquid. So this is like the reaction of baking soda and vinegar, because baking soda is sodium bicarbonate, and the reason it bubbles is because you are making carbon dioxide gas. You end up with a liquid, water, and solid or liquid sodium chloride, and you should probably add in that this is carbon dioxide gas here. The last common acid-base reaction that we're going to look at is reacting an acid with a metal to make hydrogen gas, and once again, that ionic compound we call a salt. So an example would be us taking some magnesium ribbon, solid magnesium, and dropping it in hydrochloric acid, and we get hydrogen gas, so bubbles, and then magnesium chloride is either a solid or an aqueous solution. So the reason we look at these common acid-base reactions is because if we know our balanced chemical equation of how an acid and a base are going to react and the products we're going to produce, we can use some information and mole ratios to figure out the concentrations of an acid or basic solution. So basically, we're going to use solution stoichiometry, so a mole ratio, to figure out the concentration of our acid. So in this problem, we want to know the concentration of sulfuric acid. If we have 15 milliliters and it's neutralized by 30 milliliters of 2.0 mole per liter NaOH. So like any other stoichiometric equation or stoichiometric problem, you need to start off with your balanced chemical equation. We know our reactants are going to be sulfuric acid and NaOH. Because this is a neutralization reaction of an acid and a base, we know our products are going to be water and that ionic compound or that salt. So we know from our theory that our acid is going to donate a proton and our base is going to steal the proton. So we know one of our products is going to be H2O. And our other product is our ionic compound, so our sodium and our sulfate, giving us Na2SO4 aqueous, and our plus sign right here. So just remember that a neutralization reaction is also a double displacement reaction. So your cations switch places, if that helps you. Okay, so now that you have your balanced chemical equation, you need to start with your givens. You have a volume, and you also have concentration information available. Your volume of sulfuric acid is 15.0 mils. And you are looking to calculate the concentration. Your volume of NaOH from your word problem is 30 mils, and your concentration is 2.0 mole per liter. So if you are someone who writes a strategy line out, basically your strategy is you're going to go from volume of NaOH to moles of NaOH to moles of H2SO4 to concentration of H2SO4. Okay, and before we even get started, something that I forgot to do is we need to balance this equation. So a quick look shows us that our sodiums are not balanced, so you should have a 2 here, which then makes your waters not balanced, so you should actually have 2 sitting in front of your H2O as well. So in case you need your missing pieces here, you're going to go from your volume of NaOH to your moles using the concentration. You know you're going to go from mole to mole using a ratio from the chemical equation. And then to go from moles of H2SO4, you're going to use the volume to get the concentration. So you are looking for concentration of H2SO4. We're going to start with our volume of NaOH. We're going to multiply it by our concentration, 2.0 mole per 1 liter of NaOH. Going to throw our ratio in there. So right now we have moles of NaOH on the top, and up here we have 2 moles of NaOH. So we put that 2 moles of NaOH on the bottom, and it's reacting with 1 mole of sulfuric acid. And then we take that mole to turn it into a concentration. We just go 1 over 15.0 milliliters of H2SO4. Now once again, because you have 2 volumes in milliliters, actually this volume here should be milliliters. Because you have 2 volumes in milliliters, that mill and this mill cancel each other out. So you don't have to convert it to liters if you don't want to. Punch this into your calculator and you end up getting 2.00 mole per liter. So that ends up being our concentration of our sulfuric acid. And a quick check of canceling out our units. Liters of NaOH, liters of NaOH, moles of NaOH, moles of NaOH. Leaves us with moles of H2SO4 per liter of H2SO4, which works out perfectly for what our units are. So then a quick therefore statement would finish off this problem for you. Okay, so there's your therefore statement. So flip your handout over and take a look at the example on the back of the page. In this example, we want to calculate the mass of calcium carbonate. Just note the correction for the formula on your handout. It should be CaCO3. You might have that typo. We want to know the mass of calcium carbonate, which is Tums, required to neutralize 10 mils of stomach acid, which is HCl, that has a concentration of 1.0 mole per liter. So once again, start by writing out your balanced chemical equation. We know we have our reactants are going to be hydrochloric acid and calcium carbonate. Because it's a neutralization reaction, we're going to have a double displacement of our cations. So the calcium and hydrogen are going to switch places, resulting in our products being calcium chloride and H2CO3. So now that you have your equation, give it a quick look to make sure it's balanced. Basically, looking, we see 2 hydrogens here, only 1 in the reactants, so we need to put a 2 in front, and after we do that, everything else looks like it matches up. You know by now your next step is to get out your given, so you're going to get a volume and a concentration for anything that you have readily available to you. So once we pulled out our givens from our word problem, we note that we have the volume of acid and the concentration of acid. And this time I have converted my volume to liters, and there's a reason for that. We do not have any concentration information for calcium carbonate, and we don't have a volume because Tums is a solid. I want you to pay attention to up here that we're looking for the mass of calcium carbonate. So that means we're going to have to figure out our number of moles using a ratio and then use our molar mass of calcium carbonate, which happens to be 109 grams per mole, to calculate a mass. So if you're somebody who's going to write a strategy, so for this equation, you're going to start with the volume of HCl. You're going to use the concentration to figure out the moles of HCl. Then you're going to use a ratio to figure out the moles of calcium carbonate. And then you're going to take that moles and you're going to figure out your mass of calcium carbonate using a molar mass. So this problem does not look like anything new now. You know how to solve it. So plug in your information and find out your answer. So if you set up your problem correctly, this is what it looks like. 0.0100 liters of HCl times 1 mole over 1 liter of HCl times 1 mole of calcium carbonate over 2 moles of HCl times 100.09 grams of calcium carbonate over 1 mole of calcium carbonate. I want you to note that this time I had to convert my volume to liters because no other point in the equation do I have the unit milliliters for the mill part to cancel each other out. So if you punch this into your calculator, you should get a mass of 0.500 grams, and then a therefore statement will finish off your solution. So that concludes our video lesson on looking at acid-base reactions. You want to give this a try. You've got some practice right here. But basically it's the same skills as solution stoichiometry, using a mole ratio to go from a volume or concentration to either a volume, concentration, or, like in this last example, mass.